So let's start the discussion. So my name is Amit, and full name is Amit Kumar, and I will be your discussion partner for next 1.5 hours on DevOps. Right? I have 16 years of industry experience. Out of that, around 10 plus years has been on mostly on DevOps and how on and DevOps related technologies. So administration, system administration, application administrations, operations, infrastructure operations, version control systems, anything that you can imagine can go in DevOps world. I have done that. Yeah. So been here for 16 plus years and in DevOps for 10 plus years. And right now I work as principal DevOps engineer in my organization. Right? And I will be here discussing today with you guys and brief overview of DevOps. So what is DevOps, how it came into being, and why it is used, and various tools that we use with DevOps. Okay, so that will be my topic of discussion with you. So I'm going to choose another color here. Yeah. So let's talk about DevOps. Okay. So before understanding DevOps, we should understand what is a traditional software development methodology, which is waterfall, right? So you have something called as a waterfall way of developing software, so developing software projects. And in this methodology, you have various phases in project development life cycle, right? So it's all starts with a customer. You have a customer who has a lot of money and they want to develop a software, right? So they give you the requirements. So the project teams performs the requirements gathering and analysis, right? So they perform requirement gathering and analysis. This is done by the software team along with the customer. At the end of the requirement gathering, you have an agreement with the customer on the scope, on the cost, and on the duration of the project, right? So the agreement specifies what you are going to deliver to the customer, how much it's going to cost to the customer, and how much time you are going to take. Okay, and once this agreement is done, it is almost like written in stone, and then you start working on implementing what you just discussed, right? So the next thing that you do after this is you design the product, right? You start designing the product. So you define what are the modules that are going to be used in the products, which modules or how many modules you will make in the product, what is the approach that you are going to take to build the software, what would be the architecture, which languages you will use, which technologies you will use, and things like that. So that's where design comes in. Once the design is completed, then comes the implementation part, right? Implementation is, I think, the longest running um, phase here, where you actually implement the product, right? So you code, then you test, then again based on the feedback you code more, then you test more, you code more, you test more, and this cycle continues, right? So coding to test, test to code, code to test. This just continues till testing team or the test results come out positive, and they say, all right, you're good to go for next phase. The next phase after implementation is release, right? So you release your product to the customer. The customer can now see the product. So either you release it by sending them the source code or the binaries, whatever was agreed, right? If it is a now during the release, it could be many things. Either you give them whatever you develop, source code and whatever, and then leave the customer alone, or you can also continue to maintain the product for them, right? Maybe customer says, okay, all right, why don't you deploy it for us? You find infrastructure, you deploy my application. If it is a web application, deploy my application in one of the servers and maintain it. So that is also possible. So after release or during the release, you can make a deployment, and the deployment you want to manage the deployment, right? All these things can be done. So this is what a waterfall um, software development philosophy looks like. Any idea why this is called a waterfall and not something else? You can send a quick chat message for that to answer. Yeah, it so waterfall is like this, right? So you have a mountain cliff, right? You have a cliff here, and this is a flowing water, right? And when the water falls from the cliff into the valley or wherever, this direction is predefined, right? The flow of water will always be in this direction. Can the water go back? The water cannot go back on its own. Okay, it can go back if some external force is applied, right? If somebody takes a bucket, takes some water from here, climbs up the hill, and throws the water back into the river. Hmm? So on its own, the water will not go back. Similarly, in waterfall software development methodology, while implementation, you cannot go back to customer and say, hey, we want to change the requirements. Or customer cannot come back to you, say, hey, I want to change the requirement, because it's all frozen. You cannot go back. But as I said, with external force, you can go back. So if you change the scope of the project, that means you want to add something more in the requirements or reduce something from the requirements, then it has an impact on cost and on duration. So you will have to incur extra cost, and your project will be delayed. So that's the extra force that you have to apply to go back. So generally, it does not allow you to go back in time, right? And this causes a lot of problems, right? For example, the first problem is that there is no visibility for the customer on the project development status, right? Customer does not know what is happening in the project, because he's not allowed to. At the end of the release only, he or she will see what is the project, what is the end product, right? There is no visibility. And then there is no, obviously, the changing of requirement is very difficult. So requirement changes are difficult, right? So you cannot change the requirement midway. Also, you have to complete the project even if you are failing, right? If the development team says that, we are going to fail this project, we don't have competency, or this project is too complex, well, you have to do whatever you can do, because the scope and all is defined. You cannot change anything, right? So you fail very late when you have spent so much money here. So to avoid these problems, the developers started using another approach, which is called as Agile, right? So it started with Waterfall, and now teams try to use Agile. And in Agile, what they do, they say, okay, we will not define the scope of the project. The scope of the project we will not agree upon in the beginning. Okay, we will discuss it. We will see what we have to do, what is a general idea about your project, what you want with the customer, but we will not agree on the scope. Okay, so customer says, again, the discussion happened between customer and the development team, and you still gather the requirements, right? So all the requirements are gathered. Now, what the customer will say? Customer will say, I have these in my project, I have these 20 requirements, right? So there are these 20 features which are supposed to be part of my project, and I want these to be implemented. And the development team will say, all right, you want to have these 20 projects developed, and you decide, you know, in which sequence we develop them, and which feature is high priority for you, which feature is low priority for you. So pick up any top 4 features that you want us to develop very quickly, and then rest of the features or rest of the requirements we will talk about later, right? Maybe by the time we give you these 4 features, you may have some more ideas, or based on these 4 features you may want to add some more features. So let's talk about other requirements later. Initially, let's start with these 4 requirements, okay? And we will work on it for a short period of time, and then we will give you some sort of initial prototype. So what you do here is your development team will work for short duration of times known as sprints. Maybe it's a 4-week sprint. Just an example. It's all dependent on team, how big sprint they want to run. So you say, okay, customer, choose your top 4 requirements, and we are going to pick these requirements as part of our next 4-week sprint. During this sprint, we will analyze these requirements, we will code them, we will build them, we will test them, and at the end of the 4th week, when the sprint ends, we are going to we are going to make a release, right? And when the release happens, the customer will see what is the product that is developed after this sprint, after this 4-week sprint, right? So the customer at the end of each sprint will get a minimally working product and can see how the product development is going on. So at the end of the 4-week, now these numbers which I'm talking about, this 4 or 4 here, all these are hypothetical. It can change team to team, right? I'm just taking some examples. Then the team says, all right, this sprint is done, we gave you some features, now choose what you want to be developed next. Now based on this release and how the product is looking right now, and based on the customer's understanding of the market, he can say, all right, now looks like I should need these 4 features developed, okay? And then they are taken in the next sprint. So another sprint, and now we are going to again do an analysis, and then code, then test, and then finally at the end of the sprint, we are going to make a release again. And the customer will again see what is happening here in the product development, right? So here customer involvement is quite high, and you're making frequent releases, right? So if this is your product timeline, and this is the start of the project, this is the end of the project, you're still making releases. But in Waterfall, you made a release at the end of the project, right? So in Waterfall, you will make the release at the end of the project. But in Agile, you're making releases very frequently. Correct? Every 4 weeks, you're making a release. And this works really nicely. The development team gets very frequent feedback from the customer, and the customer also sees the product very frequently and can design or understand what does he want in the product next, right? But then there's a problem with this. Not a problem, but Agile also is a bit inefficient. For example, yeah, let's talk about the actual example here. There are these four features: one, two, three, four, which are developed in an agile sprint. Right? Let's say there are four developers working here, and there are four features, and one developer picks up feature one and implements it within the first week. Feature one is done within the first week of the sprint. Okay. Now this guy has to, or this feature has to wait till the end of the sprint to be released. Why cannot we release as soon as a feature is ready to be released? Why do we have to wait till the sprint end? Yeah. So this led to more frequent releases. So what do we see here? Right. We said, all right, we will release continuously. Right. What does this mean? This means that as soon as a feature is completed, we will release it. Okay. So that means that instead of releasing every end of 4 weeks, well, we are releasing once a feature is ready to be released. Right? So no defined schedule of releases. So you can see here, initially we were able to make quick releases, then some feature took some more time to be developed, then there was no release for quite some time, then some two quick releases, then a longer time between releases. So you could make releases like this. Whenever a feature is ready, it is released. So this is much better than agile in terms of getting quick feedback from customer and also always keeping the product in the ready state. Right? Whenever there's a feature, that feature is always in production. Whenever feature is finished development, it is always in production. So this is called releasing continuously. Right? Now, to achieve this, to have continuous releases achieved, you have you need to have your all the systems in place. Okay, there is a major challenge when you want to release continuously that I will just explain with you or talk with you. So you have a development team which is working on the project development. So let's say they are working on a product called Apple Byte. Okay, they're working on a product called Apple Byte, and the development team is developing this on Java. Let's say Java 1.8, and they are going to use Tomcat for deploying this application. So let's say Tomcat 9, and yeah, so this product is being developed with this technology, Java 1.8. So traditionally, right, in Agile, when the team is working in Agile, every 4 weeks they will release this product, right? Every sprint they will release this product, and always there is a separate ops team or operations team which manages the deployment infrastructure, the services, the applications, networking, and all that stuff on which your application will run. Right? So the development team will say, all right, my sprint one is done. Here you go. Please deploy. So this create a deployment request. So here is my release package. Please deploy it. Right? Operations team will say, all right, what is the infrastructure that you need? And development team says, all right, please set up deployment infrastructure based on Java 1.8 and Tomcat 9. So the operations team will set up this infrastructure and then deploy. Right? Then comes the next sprint. Sprint 2 ends, and development team maybe said, all right, maybe we need to update our Java to make use of latest features. So we are going to use Java 1.11 and update our deployment environment also Tomcat 10 and inform the same to the operations team. Right? Development team says, all right, our next sprint is going on, and for our next release to work, hey, operations team, upgrade this infrastructure. We are going to deploy on a different version of applications, and the operations team will then plan their upgrades. They will do a upgrade of the infrastructure, and then test and validate that the upgrade is working fine, it's stable, and then they will have, for example, Java 1.11 and Tomcat 10 available on the infrastructure. And when the sprint ends, well, there is a deployment request and deployment is done, right? So teams are able to talk together, but still, there has to be a lot of coordination between dev team and ops team, right? So this works maybe okay in agile when we are making regular releases. But what happens when we are making releases all the time? You can see here the continuous releases. When we are making releases all the time, then this becomes difficult, right? Let's replay this scenario when we are making continuous releases. So the development team says, all right, we are going to develop the project with this infrastructure. Please prepare the infrastructure. Operations team will say, all right, Java 1.8 and Tomcat 9 is ready, and now we can deploy it. But now the development team is making very frequent releases. So within maybe next 2 days, development team says, okay, here's a new deployment package. Please deploy it. And the operations team will say, all right, I'll deploy it here. And development team say, all right, next day, another package, please deploy it. Operations team will deploy that again. And then somewhere in the quick releases and quick development, they also thought, okay, instead of using Java 1.8, we are going to use Java 1.11 and Tomcat 10. So they used the new versions of Java and Tomcat and whatever is required for their application development, and then said, okay, operations team, here's a new deployment package, please deploy it. Operations team will say, all right, I'll deploy it, and that deployment fails, right? The deployment fails because somebody in the development team forgot to mention to operations team that we need to have this latest environment, changed environment. So the development happened on this environment, but the operations team or operations infrastructure was still old one. So the deployment failed. Your continuous release philosophy did not work here. So the team decided, okay, we are going to talk to operations team in advance before we make a release. Let's talk to them and get the infrastructure updated. Now remember, you are making releases very frequently, maybe every day or every 2 days or every 3 days. So next time, development team says, all right, we have upgraded our technology. Operations team, a release is coming in next 2 days maybe. So make your infrastructure ready. And operations team says, well, I cannot do that. I cannot change the infrastructure as and when you want. We want stability, right? I cannot afford any downtime of the infrastructure because my KPIs, right, or my performance is measured on the uptime of the infrastructure. I cannot make any changes here. So you have to give me sufficient time, maybe a week or 2 weeks, so that I can validate whatever you are asking to me. And that's a big gap here. Development team has already moved to the latest version of the development environment, but operations team requires a lot of time for validating and upgrading the infrastructure, right? So there is a strong dependency between development and operations team, and also the incentives for development and operations team are different for different targets. For example, development team is expected to make a lot of changes. So development team will choose new features, new infrastructure, new technology, and blah blah blah. Operations team is expected to provide stability, right? So reject any new changes because infrastructure needs to be stable. So both teams are working together, but their team targets are different and actually opposite. So this leads in a lot of friction and finger pointing and blame game and all that. Okay, so this is what the teams face if they want to release continuously. How do we solve this problem? So the solution for this problem is to move some of the responsibilities of the operations part towards left, which is the development. So development team also starts doing some of the operations, right? Maybe manage the software that is running on the infrastructure, or maybe manage how the application is deployed. An operations team just takes care of basic underlying physical infrastructure, but on everything on top of that, DevOps team does. Okay, so the solution is to bring dev and ops together, and that's what DevOps is about. DevOps is about building developers and operations together so that they can achieve continuous deployments. That's what DevOps is all about. All right. How do you bring dev and ops together? By first of all, making both of the team understand DevOps and why it is required, and getting them on the same page, and then having some tools or processes defined so that the development team can actually work very closely with the operations team. Right. This requires competency increment in developers, cultural change in how the entire organization works. This also require operations team to relinquish some controls, give more access to the development team, adopt new technologies to enable development teams to make their own changes. Right. So that's there are a lot of things that go behind the scene in implementing DevOps, but the end result is that the development team is more capable of managing their own product. Yeah. Questions? Do we have any questions? So I'm open to questions via chat before I move to the next topic. Okay, so no questions. Then let's move on to the next one. Now let's talk about what are the various processes that you can implement to enable DevOps in your organization. Right. So let's talk about those. So end goal is to make continuous deployments. Your team wants to make continuous deployments, and how do we enable that? Okay, so I'm going to choose a different color here. So what happens? Well, when your project is developing, right, or when your developers are working on a project, you have a storage or a repository where you store your all project files, right? So your source code, your configurations, etc. They are all stored in a version control system. Right? For example, Git. Okay, and the developers, well, they work with the version control system to make any changes on your project data. Right? Now, as soon as a feature is completed, you want to deploy it. You want to deliver it. Okay, but then how do you do that? That's a bigger question. How do you deliver every feature that is developed? So what you want to do is, first you want to validate all the changes that are happening in your project repository, right? So any changes that are happening in your project repository here have to be validated so that you are assured always that your project is always ready to be released, right? And you can do that, right? For example, implementing a continuous validation process. So you want to validate any changes. So let's say this is developer one, and developer one said, all right, my feature is finally submitted in the project repository. So source code is changed now. As soon as it's done, you want to compile it, right? If compilation is all right, then you have some confidence that okay, this change looks okay. Then you want to test it. Maybe unit test, system test, regression test, any test that you want to do. You want to test it. Right? After testing, you want to maybe analyze the source code, right? So your source code metrics is generated. Your source code metrics is generated so that you'll see that your code has not a very high complexity. There is no memory leaks. There are no um, um, unwanted functions. The open source or public source code that is used is free of any bugs or any vulnerabilities. So you do all that check, right? And finally you say, all right, we are ready to release. So you package your application as well. So for every change, every major change that is happening on your Git repository, you want to continuously validate that the change is actually a good change. Okay, so this is called as continuous integration. So this means that any change that is coming in your repository is continuously integrated. That means continuously validated and verified that it actually is a good change and it is fit for being a part of the project, right? So you perform continuous integration. Now the next thing that you want to do is you want to release it, right? As soon as a change is implemented and your entire process is satisfied here, then you want to make a release, right? So to make a release, what you do? All right, let's deploy it in staging. Well, releasing means giving the project to your customer, right? So you give it to your customer by deploy it in a staging environment. What is staging environment? Staging environment is an environment where you want to deploy application which is identical to the production environment, but it is used only by your customer, not by your end user. So your customer can perform their own tests on this environment. So you deploy on the staging and they can perform user acceptance test on the application that you just deployed, right? So what you're doing now, you are continuously integrating your every change, plus you are delivering your product to the customer, right? You are delivering your product to the customer here. This is called as continuous delivery. When you deploy to the staging area and the customer has the latest release, not the end user who is going to actually use the product at the end, but the customer, right? For example, if you are developing a product for Amazon, let's say you are an organization and Amazon asked you to develop a web application. Now you develop the web application and give it to Amazon. Amazon is your customer, but at the end Amazon will deploy it somewhere, and your end users like me and Amazon customers will use that application. So they are end users. So your application is still not available for end users, it is still with the customers. Okay, so you deploy in the staging area and customer will do a UAT. And after the UAT, customer will say, okay, go ahead and deploy it to production, or let's wait for more releases, or whatever is the decision. Okay, so this is called as continuous deployment or delivery. All right, now you can say, well, I can also automate this UAT. If I get enough support from the customer, I can also automate this UAT. So if I am, for every major feature change, I am running this continuous integration, I'm validating all the changes, and then I'm deploying to staging area, and validating based on customer acceptance criteria as well, then what is there to wait? Why cannot we just release it? Yeah. So you will want to then actually deploy it in production. You want to deploy it in production automatically. It it requires a lot of automation. So your compilation, testing, everything should be automated, including the user acceptance test. And that's when you say, all right, now we deploy it to production here. And if you do this, this is called as continuous deployment. Now, any change that this developer made this change, and it was subjected to continuous integration and continuous delivery and continuous deployment. Automatically, it's going to change, or it's going to be delivered or deployed to the customer. Right? This is the end goal here. Now, to achieve this pipeline, well, it looks very simple and it looks very exciting. Okay, let's do this. But to achieve this pipeline, we require a lot of tools and technologies to enable this. Right? For example, the first thing that you immediately require, let me choose a different pen here. Yeah, this color is fine. So first thing that you immediately require is a version control system. This is your primary requirement. You need to have a version control system, and that's a very easy part. Now you need to have automations here. So you need to have automation on compilation, automation on testing, and all kinds of testing. Right? So you may want to have, for example, unit tests. You may want to have regression test. You may want to have system test. You may want to have performance tests, whatever, right? So you want to perform all those tests. Then you need to have automated, source code metrics also. You need to have automated package creation also. You need to have automated deployments also, right? So how do you do all that? You need to have automated user acceptance tests. You need to have automated production deployment. Now, this is from your source code perspective, but then you have to manage the infrastructure that is running all these pipelines, right? So you need to manage servers management. So what do you mean by server management? You want to provision some servers to run all this pipeline, right? You want to maybe configure the servers as well to run this pipeline, right? How do you manage your entire infrastructure and servers so that this pipeline is always healthy? That is also required here. It is not related to source code, but it is related to your complete infrastructure. That's where ops also comes in. So all these things need to be done, and they need to be done um, to achieve your continuous deployment via DevOps. Okay, so this becomes your continuous deployment pipeline. Any questions on this pipeline? Question is, what is the difference between continuous deployment and delivery? Well, as I said, the delivery is to the customer and the deployment is to the end user. Okay, who is a customer? Well, customer is the person who is requested the application or the product, like Amazon for me. If I am a software developer, Amazon says, hey, Amit, develop this web application for me, which I will then expose to my customers. Yeah? So my customer is Amazon. And whenever I am done with my web application, I will give it to Amazon. That becomes a delivery to the customer. But then Amazon internally will say, all right, my customers are the end users, the actual Amazon customers. So they are the end users. They will end up using the application. Amazon will not use the application. The end users will use the application. So the end users are the actual users of the application. The customer is the person who or is the organization who is actually uh, uh, producing the application. I hope it makes sense. Can you please let us know the difference between staging and UAT? Well, UAT is test. Staging is a deployment, right? So you want to deploy your application on some infrastructure. You just call it staging because you want to stage it there so that it can be validated by the customer. Yeah. So UAT is test that is performed when your application is available in the staging infrastructure. Okay. Question: does Android updates feature waterfall or agile? When you say Android updates, are you talking about the Android application, individual application updates, or the operating system updates? And bugs and patches after release are fixed in this way as in the pipeline? Yes, bugs and patches, whatever goes in the product, always goes through the pipeline. Okay. Okay, so Android operating system updates, well, we don't get the OS updates very frequently, right? So, well, the product development is, I cannot say that it is completely agile. Well, there has to be a defined scope of the development, but I mean, Android OS update is a set of hundreds or 200 projects, individual small projects, and that becomes the operating system update. So I will call Android OS update as a big program of small projects. Okay, so yeah, are you going to explain a set of tools to cater this? Yes, I'm going to talk about those as well. Is staging pre-production environment? Yes, something like that. Staging and test environments are same or different. They could be same, they could be different. Generally, test environment is where you set up for internal testing, and staging is where you set up for end user, not end user, customer user acceptance test. But it's just terminologies. You can call anything. Uh, 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 is it a best practice to get consent from the customer while staging? Well, staging is staging. Yeah, you can always update it there. It all depends on the agreement with the customer, obviously, that how frequently you can stage. Maybe the customer is using staging environment for their UAT. They are doing a UAT, and suddenly a new update comes to the application, right? So then their UAT is not completed, and then you release a new version. So you have to also align about all these things with the customer. Okay. So is any question unanswered? I think I try to answer all the questions. Ayappa has a question: is any training is available? So I let SkillUpRight team answers this. What kind of trainings they have available for this? Okay, all right. Okay, so let's go back to the discussion here. This is our pipeline. Now, what are the various tools that we use to achieve this continuous integration and deployment and delivery that we have talked about, right? So, uh, we talked about version control system, continuous integration, continuous delivery, continuous deployment, server management, right? What are the tools that we can use to achieve this? Well, there are a lot of tools and there are a lot of options. So if I could just quickly get a image for you, give me 1 second, yeah. Yeah, just give me 1 sec. Yeah. So I'm not sure if many of you have seen this image before, but this image represents how DevOps works and what are the tools that you can use, right? So maybe if I choose a highlighter here, just give me 1 sec. Right, so these tools here, and yeah, for example here, right? So when we talk about DevOps, we always talk about this, infinity DevOps loop. That means we are continuously doing everything. We're continuously planning for new features, building the feature, then continuously do integration and then deployment. That means release and operations as well, if we are managing the application, and then get feedback from the customer and then continue to incorporate that in our plans and make continuous releases, right? Now for planning part, you can use many of these tools, like there is Jira somewhere, I don't know if it is here. There is Asana, there is Lucid Chart. So for planning, you can use many of these tools. Then for developing your applications and building your applications, you can use version control systems like Git or GitLab or GitHub or SonarQube, Subversion. Then for packaging your applications, you can use Docker or npm, um, and things like that. Now for continuous integration, you can use Jenkins, TeamCity, Circle CI, whatever you want to use. Then for deployments, you may want to use some deployment technologies like Ansible or Chef, even Kubernetes or Docker, or Packer, HashiCorp Packer, or Nomad, or whatever you want to use, right? And then for operations, again, you can use monitoring, data analysis. Also, you can use these underlying technologies like Kubernetes or Ansible and all to manage the upkeep of the applications. And for continuous feedback from the customer, you can use certain tools like Salesforce or Freshdesk or Zendesk or Cucumber or whatever, right? You also need to enable real-time communication between the teams, but this is more on the cultural part, not the tools part. But you can use many tools here like Slack or Microsoft Teams and things like that. Okay, so the tools landscape is actually quite huge when you talk about DevOps, right? Now, in this pipeline here that we discussed, we will have, I will talk about certain quite popular tools. Okay, so for example, for version control systems, we always tend to go with Git. So Git is the de facto version control system in today's industry landscape, right? For continuous integration, you may want to use Jenkins if you have on-premise or multi-team um, CI solutions if you want. Otherwise, you can also choose, if you're on cloud and if you're fully on cloud, you can use a managed service like Azure DevOps or AWS DevOps tools, right? Many cloud tools provide these services. Then for individual, these components of your CI and CD for compilation, you can use a build system like maybe Maven or Gradle or whatever you want to use. For tests, you want to use some test framework. For metrics, you want to use some framework. For packaging, you may use some framework. So these things, this compilation and this test, all these things actually fall into developers' responsibility. So they have to identify which framework they want to use for these use cases, right? As a DevOps engineer, from the infrastructure perspective, these things don't matter to you. Then for packaging, you can identify how the package is going to be created. Maybe you want to you receive or you create a deployable war file. For example, it's a Java based project, and then how do you want to package it for further delivery? Maybe you want to create a Docker image out of it, right? So you want to create a package which is built into a Docker image, and then you use Kubernetes as your underlying infrastructure to deploy this application based on Docker image, right? So Kubernetes staging environment, Kubernetes deployment production environment, and then when you create a package, you can deploy it on the staging using Kubernetes, perform your UAT, and then deploy on production using Kubernetes and perform your uh, or have the application running. Right now, to manage all these underlying servers, your Kubernetes servers, your Jenkins servers, your Git servers, you may want to use certain server management solutions. For example, if you are on cloud and if you want to work with provisioning of new servers, you can use, for example, um, Terraform, HashiCorp Terraform. You can use. There are other tools also. For example, there is Pulumi and many other tools, but Terraform is quite popular for configuration of servers, right? Once you have servers and operating system available, for configuration on top of that, you can use a configuration management tool like Ansible, right? This is very popular. If you want, you can go with Puppet as well, but Ansible is quite popular these days. Okay, these tools are called as infrastructure as code tools. So you want to manage your infrastructure as a piece of code itself. You don't want to deal with manually clicking on some buttons or logging into machines and manage your infrastructure. You just want to write them as a piece of code and configure them. Okay, so Git is for version control, Jenkins is for your integrating all these tools together to perform a CI pipeline, and then you have your deployment environments for deployment of applications, and then you have infrastructure as code environments for configuring those infrastructure components, right? So when you are starting your DevOps journey, these are the basic tools that you need to know. If you want me to summarize the top choices of these tools, I will write them as like this. You should know Git, you should know Jenkins, right? And then you should know a build system, for example. Let's say Gradle is a good choice, right? Or Maven, but Maven is very Java specific. So it becomes very domain specific, but Gradle is very general purpose. So you can use Gradle also. Then you should know about, deployment infrastructure. So Docker is a must these days. And same goes for Kubernetes. All right. And then for your infrastructure as code needs, you should know Terraform and Ansible. Okay. And I think it's a good idea to always have some awareness of cloud, and you can always start with AWS, or you can choose based on your requirements. Azure or GCP, these are the major cloud providers. Then, if you are very unfortunate and your organization is using some other cloud provider like DigitalOcean or Alibaba or Oracle, you can use those as well. But I think it's a good idea to start with AWS. Okay, so yeah, these are the tools that you should learn as a basic starting point for DevOps. And then when you learn them, you will see that just learning them is not enough. You need to go deep to understand how these tools work, how they are architected. And for example, Kubernetes is like an endless well. You can just go deeper and deeper and deeper, and you will find something new, and then you will find a lot of directions that you can move on to um, really learn, right? Cloud. Well, cloud is like multiple endless wells, right? AWS has 100 at least services available for you. What if various use cases and for various uh, uh, requirements, and you can just learn and learn and learn, and it's not ending there anywhere, right? Jenkins, yeah, just Jenkins is quite versatile and allows you to create your customized pipelines on your systems. Git is a pretty staple tool. Every team should use it. Everyone should know Git. Even a basic developer should have basic Git understanding. Okay, so all these tools I always recommend to start learning. Some testing tool also maybe you can learn, but testing tools are always domain specific. For GUI testing there will be other tools. For unit testing there will be certain tools. So I think testing is a complete domain in itself, and this should be left to the actual test engineers to write test automation and to identify testing frameworks. The DevOps guys don't need to go into much detail of doing this. Yeah. What else? Then you should also learn about logging. How do you log? How do you manage the logs? About monitoring your infrastructure or monitoring your application. So various tools like that. For example, Elk can be used for this. Prometheus can be used for this monitoring part. So you should learn these tools as well. Yeah, so these are the I think the tools which you can start with for beginning your DevOps journey, and then slowly build up on this. Question: is UAT a kind of customer test? Yes, UAT means user acceptance test. Does your customer accept your product? Okay. Are you going to explain more on Azure DevOps, or is it a generic session? So it's a pretty generic session. I'm just giving ideas about, various technologies that you can start learning. But it's mostly a generic session. Yeah. Is UAT environment similar to production? Yes. So the environment on which you do a staging and the user acceptance test has to be technically similar to production environment. Otherwise, you may test something else and deploy something else. Before Docker or Kubernetes, how the deployments happen? Well, right now also, it's not necessary that you deploy only using Docker and Kubernetes. You can just deploy as vanilla deployments as well on the server or on virtual machines. You can do that. Right. So using, for example, for Java applications, you can use Tomcat and run your application there, or you can use maybe other web servers like Nginx or Apache HTTP servers to run your applications, right? So not always required to have containerized deployments. With the advancement of no code or low code platform, does it impact DevOps? Well, I'm really not convinced with no code uh, way of development. It is very limited, and it is limited to very, very specific use cases. So yeah, I'm not 100% convinced with this low code uh, fad that is coming in. And I don't think, because it has a very, very specific niche user base or adoption, I don't think it's going to have any impact on DevOps as such. If agreement is not fixed scoped, could you mention pricing parameters, as milestones too are undefined until UAT? Well, pricing could be based on duration, right? You can commit resources and not commit the duration. You can say, all right, here is my team. We are going to work in sprints. You are free to specify requirements in advance, list down the requirements, and we can see, maybe approximately what could be the duration and what could be the pricing for the project. And that also is not written in stone, right? Duration also may change, obviously based on correct alignments, but that also can change. Can you please share the list of tools by area wise in email? Well, I mean, in email will be very difficult, but I just gave you some idea here, right? These tools here or here, right? Maybe I can share with you the URL for this image, and that can maybe help you out. You can refer to it later. Are you provide any session for Docker, Kubernetes, and Ansible? So I will let SkillUpRight team answer this. Are we going to have recorded sessions available? So Vinod, you want to take this up?
Amit, it's already recording. We will share.
Okay, so you will receive the recordings. All right. Exact way of or exact mechanism of how you will receive the recordings, I am not sure. You can always get back to the SkillUpRight team. Sessions for Docker, Ansible, and Kubernetes. Again, that I am not sure if Vinod, you want to take this? I mean, the training requirement that is coming here from Prasanna, there is a question.
We will check with Tech Mahindra L&D, Amit.
Okay. All right, guys. So yeah, so Tech Mahindra Learning and Development Department. I think the discussion will happen there. Are there any specific challenges while we are working with legacy systems? Yes, a lot of challenges. Legacy systems are called legacy because they are not there is very less benefit on in changing them or upgrading them or migrating them to newer technologies, right? So those systems are set, they are working perfectly fine. Nobody wants to touch them because there is very less return of investment. So generally these DevOps and these new technologies don't go very well with legacy systems. In Jenkins, if deployment fails, then how it manages when it is automated? If deployment fails, it fails. It gives the notifications to the developers, and then some human intervention is required to perform root cause analysis and to see why something failed. Any more questions? DevOps ends at deployment or it continues after like maintenance and support. So DevOps is a software development methodology, right? So obviously your project may have support mechanisms or maintenance and things like that. There is very little that DevOps can do there unless it requires still active development. So yeah, DevOps is mostly applicable when you have active development and sustenance or maintenance that can be managed without DevOps also, like a normal project. Important KPIs to track a project. From DevOps perspective, yeah, so there could be many KPIs that you can define. For example, you can define how many releases are we are making in a defined time interval. We can define how many releases are accepted by customers or how many bugs we are receiving, to get an idea about the quality of the features that we are delivering. So we can have many KPIs like that, and these are the important ones which I just mentioned. Jenkins, Kubernetes, and Ansible are open source tools. Yes, Jenkins and Kubernetes and Ansible all are open source tools. There are also commercial versions available. So many organizations want to have some support from the vendors, so they also go for commercial solutions. For example, for Kubernetes, there are some vendors who provide enterprise solutions like OpenShift or Rancher. There are also managed Kubernetes services on cloud, so you can go for them, but there you have to pay. Same goes for Ansible, right? Ansible is open source, but then Red Hat Ansible Tower is a paid solution from Red Hat with enterprise support. Can email notifications be configured throughout the pipeline? Yes, email notifications can be configured throughout the pipelines. Any session with small image code implementation and deployment? Unfortunately, it's not planned for today's session, Rahul. Which tools we can refer to for monitoring? So for monitoring, you can always start with the latest and greatest and most sought after tools. For example, right now it is Prometheus. Prometheus is a tool that is used for your application monitoring, also your infrastructure monitoring. So you can use that. For traditional monitoring, you can use Nagios or Zabbix or something like that. So you can do that as well. Will all these tools work on cloud like AWS and Azure? So you can use these tools on your cloud infrastructure also. For example, if you create virtual machines on your cloud provider, you can install all these tools and be happy. They all will work there. They are also available as managed services. So um, so if you want to go with a managed service, like your cloud should manage the application for you, then many of the tools are available like that. For example, managed Kubernetes is available. Managed infrastructure as code is also available on many cloud platforms. Git and GitHub, are they different? So I'll give you an example. A movie is a movie, right? But you can get a movie from a hosting service like Netflix, right? Or Hotstar. They all serve movies or videos, but they are hosted on their websites. Similarly, Git is a way to store your project. Git stores your projects, but where do you store them? How do you host them? How do you make them accessible to other users? That is done via GitHub. So GitHub is a hosting service for Git repositories. How the DevOps person responsible with Dev and Ops team while doing the infrastructure updates? I have no idea what this question is. What is the question? How the DevOps person responsible with Dev and Ops team while doing the infrastructure updates? Can you please clarify this question? So, Venu, can you please elaborate? What is the question? How the DevOps person responsible with Dev and Ops team while doing the infrastructure update? Is the question like how the DevOps person communicate with the Dev and Ops team while doing the infrastructure updates? Is that like that? Okay. So when you are making infrastructure changes, then obviously communication is the most important part, right? You need to tell your all the stakeholders, the team who is developing or deploying the applications and team who is maintaining the applications, that okay, there is some change coming in, so there may be downtime, um, there may be some interruptions to the service. So this all has to be aligned. It's more on the process part than on the tool part, right? So this should be proper alignment with all the stakeholders. How can I deploy code to cloud from on-premise Git? Well, you need to have connectivity to cloud. So if you have an on-premise Git solution, then you can use maybe you can connect to your cloud provider via some sort of cloud provided solutions like direct connect or some VPN solutions, and then deploy your application. So this is a tricky part. Many organizations, they want to keep the source code on premise and just want to deploy the applications on cloud. So you may want to identify this connectivity there. For such solutions, the cloud providers do provide some out of the box solutions. Yeah. Okay. Thank you for all these questions. Really nice questions. Really, interesting questions. And I hope you guys could understand the basics of DevOps. What is DevOps? How does it work? What are the various tools? What is the landscape of DevOps? Why do we use DevOps? Right? And hopefully, I was able to answer your questions to your satisfaction. Unfortunately, we it's time now to wrap up the session. I also would like to apologize again for starting the session a bit late because of technical issues, but hopefully we could cover all the topics during this time. Yeah. So thank you again for joining the session. Thank you for giving me the opportunity to talk about DevOps, and hopefully I will see you again. Thank you, everyone. Have a good day. Have a good weekend coming in, and take care. Yeah. Thank you. Bye.